This video tutorial will introduce the concept of logic gates and truth tables. In this simulation here, we have the concept of an alarm at home, a burglar alarm, and we have a switch on a door that will give a signal when the door is open. So we have a gate here, which is called an AND gate, and the AND gate will allow electricity through to the light bulb to the alarm only if this switch is on and this switch is on. So both switches have to be on before we turn the alarm on. And the reason we want that is right now these are both off. So let's say this alarm's off and the family's at home and the son comes in, the door opens and it closes. Daughter comes in from school and it opens and closes. The alarm doesn't go on because people are coming through the door normally. But then the family goes out for dinner. So they switch the alarm on, they leave the house, and the local burglar decides to come around and opens the door, and then the alarm goes on. So only if the alarm is set and they open the door, then the alarm will be set to on. So this is an AND gate, and we can use something called a truth table where we have the alarm, the door open, and we found out what conditions will set the alarm to on. So with truth tables we start with one column and we do 0 0 1 1, then 0 1 0 1. The reason we do this is because it includes every possible combination of two variables, two binary variables. That means variables that could be in one state or another, a 0 or 1. So that's every possible combination. And so with the AND, X and Y equals Q, we're going to have the alarm bell ring only if the alarm is on and the door is open. So we put a 1 in here because a 1 equals true. But if the alarm is off and the door is not open, nothing will happen. If the alarm is off and the door is open, when the son and daughter are coming from school, we don't want the alarm bell to ring. And if the alarm is on and nobody comes through the door, we don't want the alarm bell ringing, and this should have been a 0. We don't want the alarm bell ringing and disturbing the neighbors. So with that alarm on, the door open, the bell will ring only when we have a 1 here and a 1 here, and we'll get a 1 in this column. So this is the only time that we'll get an output on Q or ring the alarm bell. So now what we're going to do is we're going to look at a slightly more complicated situation where we have an alarm for the window. Unfortunately, the local burglar got wise to the situation of the alarm on the door, so he climbed in through the window when the family was out to dinner. In order to stop that from happening again, they set an alarm on the window. But in order to do that, we need to trigger the alarm if the door is open or the window is open. And we wouldn't use an AND gate here, because if we use an AND gate to wire this, then you'd have to simultaneously have someone climbing through the door and the window at the same time, coming through the door and climbing through the window at the same time, in order to get a signal out the other side. So we use an OR gate. So if the door is open or the window is open, then we get a signal coming through the other side. And we take this and we feed it into our AND gate as before. So when we open the window, because it's hot, we don't have the alarm going off when the family's at home. When the children come in from school, go in and out through the door, we don't get a signal. But when the family goes out to dinner and they set the alarm and somebody climbs through the window, then the alarm goes off because this one's feeding through here. Or if the family goes out to dinner and the alarm's set and somebody comes in through the door, the alarm goes off. And this is an OR gate. The truth table for an OR gate looks like this. Now it's slightly more complicated because we've got X and Y or Z equals Q. So when you get something a bit more complicated, sometimes it's easier to work out this part of the equation first and then work out the second part. So the first thing we'll do is we'll look at Y or Z. Also, when we get a third variable, when we introduce a third variable, in this case we now have 4 zeros and 4 ones, and this is the same pattern as before, and we simply take this pattern and we copy it down. 0, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1. If we had a fourth variable, we would do the exact same thing, but we'd add all zeros down here, and then all ones, and then we'd copy this entire pattern down for 4 variables. So this gives us a nice way of covering every possibility. But let's focus on this right now. We're going to focus on y or z. Now with a y or z, whenever we have a 1 value in either y or z, then we get a 1 over here in y or z. So if somebody comes in, no one's coming in through the door or the window, so we get a 0 here. Let me highlight this. Somebody's coming in through the window, so we get a true value coming out this side. Somebody's coming in through the door, and we get a true value. And somebody's coming in through the door and the window. It's a gang raid, and we get a 1 value here. Now, because we've copied this down, because we have a third variable here, we just simply repeat this pattern down here for the y or z. So here's y or z. 0, 0, we have a 1 here, and we have some 1s here, so we get 0, 1, 1, 1. So we copy that pattern down. This is just the y or z. Now what we're going to do is we'll take the highlight off of here, and we will look at x and y or z. So now we've calculated y or z. So we have y or z, and now we're going to look at x, and we're going to look for an and. So remember, from this example up here, when we do an and, we're looking for a 1 in both values, and then you get a 1 here. So the only case you get a 1 here is if both of them are true, or both of them have a 1. So here we have both having a 1, these two have a 1, these two have a 1. So these are all 1. And in this case we have a 1 and a 0, so that gets a 0. It would have a 1 if you ordered it, but we're ANDing it, so we're looking for 2 1s. And of course, if these are all zeros, we're not going to get 2 1s. So that's the quick way of looking at that. So the rest is going to be 0. So the only time, in fact, you have true, there's these 3 conditions here, when we have the alarm is on, and somebody comes in through the window, or the door, or both. So there's only 3 conditions where you get a true, and that is the window, the alarm being on, the window, the door, or both. Obviously all of these are the alarm being off, so you'll never get a true. So these are the only conditions where you could get a true, and that's how you can work it out in a truth table. So that's a brief introduction to the truth tables and the ands, and we'll look very quickly at a not. There will be times when we need to use a not gate, which will invert or give the opposite signal. So in this case, when the switch is on, there's power coming here, there's no power coming out. When there is power coming here, there's power coming out. And we might use this in a window. If you imagine a window with the proximity switch, that's a switch when the window's closed, the 2 points are connected together, and we're going to get some current flowing. So the current flowing through it tells us that everything's okay. So when we have a positive signal here, electricity flowing, then we know the window is closed. So that's fine, we don't want to set the alarm off. But if somebody lifts up the window, and we no longer have, because it's broken the circuit, then we want the alarm to be sounded. So there'll be cases when the absence of a signal will want to detect the absence of a signal, therefore we can fire it into a NOT gate and we can invert that and it will come through, and here we'll feed this. Coming back to the truth table, we'll find the value for NOT Z first, and it's just going to be the inverse of Z. So where we have a 0 here, we have a 1, where we have a 1, we have a 0, and we just keep repeating that pattern here. Now that we have NOT Z, by inverting Z, we can now look for Y or NOT Z and calculating here as we did before. Remember, this is OR, so we look for a 1 in either of these. So we have 1, here we have a 1, here we have a 1, a 1, and a 1, and a 1. And now that we've calculated our y or not z, we can go on then to AND this with x and y are not z to come up with our new equation for q. So now let's rework our equation for q. So we have x and y are not z, so we have a 1 in these two columns, so that's 1, this remains 1, this is 1 because it's y or z, and in this case we have a 1 and this should be AND. I was ORing it. This is x and y or z. I should have been ANDing it, so I need a 1 in both. So here I don't have a 1, so that's set to 0, and in this case I have a 1 in both, and of course here I don't have any 1s, so this is my new truth table here for q. So what it means is that we're going to ring, when we have a 1 here, that's true, so I'm going to ring the alarm bell in these three instances here, and there's the values for x and y. And that's the basis of truth tables and logic gates. Thank you.